Good afternoon, everyone, and thanks for being here. Today's topic is introduction to Visual Slam or VSLAM. So when Jeff approached me for this topic, he said he wanted some type of a gentle introduction for folks that are getting into doing SLAM. So without getting into equations, make it more mechanical and fun and easy to understand. So hopefully we made it in that direction, and it's you learn a bunch of things about SLAM today if you don't know about them. So as the host said, we'll be doing this presentation in two parts. So I will present the first half, and then my colleague Srini will cover the second half of the presentation. So agenda for today's talk, we're going to go over what is SLAM, what are some of the applications of SLAM, maybe how it works. Some things we'll probably walk through one of the use cases like the feature detection, what we do about combining different sensors. And as we said today, it's 2024, we have to talk about AI or generative AI. So adding AI into SLAM also is something that we have to cover. So let's start with the basics. What is SLAM? And what is SLAM short for something? So it's short for Simultaneous Localization and Mapping, and VSLAM is just Visual SLAM. Now, by definition of SLAM, if you read through it, it's one method used for autonomous vehicles that lets you to build a map and iterate and localize your vehicle in that map at the same time. It's a very complicated definition, at least for me. A simple way to understand it is, if you're a camera, try to understand your 2D or 3D position in an environment and build a map of that environment. So as you can see from some of the illustrations over there, the one on the bottom shows your typical robot vacuum cleaner that uses SLAM. If it weren't using SLAM, it would probably go randomly all through the room. But the idea with having SLAM is you have some perspective of the room, and then you can have a much more calculated trajectory to figure out how you want to efficiently clean your room. And that way you also are more cognizant about battery life and not going over the same place over and over again. Now, SLAM is obviously computationally expensive. Previously, it was run on racks of servers, but now, as the technology has improved, we are able to implement real-time versions on various pieces of hardware, whether it's CPUs or maybe even embedded systems at this point. So the bottom picture over there is a picture of the trunk open from, I think, the car that won the DARPA Urban Challenge in 2007. I think this is the Carnegie Mellon car. So you can see there's a whole rack of Intel Xeon servers over there and water coolers and everything. Obviously, we can't do that for real-time SLAM right now because you can run it on your phone.